Today on Cllctn Math, we're talking data collection and experimental design. Intro. Okay, good day. I'm Professor McCulley. This is Math 130, Intro to Statistics, Lesson 3 on data collection and experimental design. Our goals for today: we're going to design a statistical study and know how to distinguish between an observational study and an experiment. We're going to collect data by using a survey or a simulation. We're going to design an experiment. We're going to create a sample using random sampling, simple random sampling, stratified sampling, cluster sampling, systematic sampling, and know how to identify a biased sample. Knowing how data is collected in statistics is very important. To do it properly, many things must be considered in an effort to ensure that data is collected in a manner that reflects what is being studied and a necessary attempt to reduce bias. This is another definition-heavy lesson that discusses the guidelines and the methods of data collection. We will also discuss some of the things that you can do with sample data once you've collected it. Let's get started.
Starting off with first thing here, guidelines for designing a statistical study. First thing you're going to do, you want to identify the variables of interest in the focus and the population of the study. So what are you talking about? Are we collecting data on students and how they're doing on their standardized testing, and what's that going to be predictive of? Will, if they do good in math as a third grader, will they do well as a freshman in high school? Something like that. So we're identifying our population, talking about what are the variables of interest. Then we're going to develop a detailed plan for collecting the data. If you use a sample, make sure that the sample is representative of the population. If you are talking about a boys and girls school, probably not a good idea to take a sample of just girls, unless, of course, you're talking about an instance that applies to girls. You're going to collect your data, describe data using descriptive statistics and techniques. Remember, your descriptive statistics are going to be things like your mean, median, and mode. You're going to talk about your outliers. You're going to talk about your standard deviations. You're going to talk about your measures of variation, measures of position. And you just start by going through some of that stuff. And that gets you at least a strong start. Then we're going to talk about interpreting the data and making decisions about the population using inferential statistics. We're going to find out that our sample is going to give us a fairly good idea of what's going to be happening in the entire population. And then finally, we're going to identify any possible errors. It's good for us to find our own errors and and take time to be rigorous about our experiments or our studies and try and identify things that might affect the outcome. And that way, when someone else reads your study, you can say, hey, we've already considered a number of these factors. The next slide. A definition: an observational study is a study where a researcher observes and measures characteristics of interest of a part of a population, but does not change the existing conditions. So here's an example of an observational study. 800 students are asked about the amount of television that they watch a week. They were divided into 3 categories: low usage, 1 to 3 hours a week; medium usage, 4 to 10 hours a week; and high usage, over 10 hours a week. The researchers looked at which group was more likely to be obese. This is observational because they didn't ask any of these people, these 800 students, to change their behavior. They're just looking at what they're already doing. An experiment. In an experiment, the subjects of that experiment are called the experimental units. So we got some definitions here. In an experiment, a treatment is applied to part of the population. So you're going to do something to part of the population. You're going to leave the other part of the population alone, or do something different with them. And then you're going to examine what happens to them after that. The part of the population that gets the treatment is called the treatment group, and their responses are observed. Second part of the population may be used as a control group in which no treatment is applied. In many cases, though, the experimental units in the control group may be given a placebo just to kind of give them the thought that they might be also getting whatever treatment that is. And in the case of when they study for medicines, it's usually like sugar water or a sugar pill or something. So they're given a placebo, a harmless fake treatment made to look like the actual treatment, and we'll talk about that later. So an example of an experiment, 400 students were randomly assigned to 3 groups. Group A was asked to eat an additional 600 calories a day in gummy bears. Group B was asked to drink an additional 600 calories in soda. Group C was given a flavorless, no-calorie syrup and told that it had the additional 600 calories that they were supposed to
Eat each day.
The researchers looked at which group gained the most weight. And so in this one, we would say that our control group is group C, because they're given something that is the placebo and not necessarily an additional 600 calories, even though they're being told that. And trying to see maybe there's a difference between sugar and maybe high fructose corn syrup and soda. So I don't know what they're going for with this particular example, but this clearly is an experiment because we are asking these 400 students to do something different. When you're talking about data collection, simulation versus survey, in a simulation, we're talking about a mathematical model that involves a simulation. So we may not actually be having people as our subjects because we want to study a situation that might be dangerous to them in real life. And data collection may involve computers. In a survey, we're talking about an investigation of one or more characteristics of the population. This is most often carried out by people asking questions, often done by interview. And when you're writing your questions, you should limit your bias. And clearly, there's certainly a lot of ways that you can ask a question that has a bias in it. And this is kind of an over-the-top example, but it gets us in the right path. So you could ask somebody, so what year did you stop beating your wife? And that's clearly a biased question because it implies that you're already doing something that you shouldn't be doing. Experimental design. A well-designed experiment must include 3 key elements if it is to produce meaningful and unbiased results. There must be some sort of control, there must be some sort of randomization, and there must be some method for replicating the results. Let's talk about control. Control is making sure that the experiment has valid and unbiased results. The placebo effect is a true thing, and when a subject reacts favorable to a placebo, when in fact the subject is given a fake treatment, your mind is a powerful thing, and there are quite often, if you are given something and you tell somebody that it's going to make them better, if they believe you, it can have a effect that does improve whatever it is that you're claiming to cure. Blinding is a technique where subjects do not know if they're taking a treatment or the placebo. So you basically line them all up, and some get the treatment, some get the placebo, and they don't know. Double blinding is a technique where neither the subjects nor the experimenter know which subjects received the treatment and which received the placebo. In addition to the placebo effect, sometimes if the guy who is actually giving out the real treatment might tip his hand, and the people who are getting the treatment actually know they're getting the treatment, and so they get like a double bonus effect. They get the placebo effect plus the effect of the treatment, whatever it is. So sometimes we use the double blinding technique. Randomization. Randomization is a process of randomly assigning subjects to different treatment groups. There are a number of methods of randomization. A completely randomized design, subjects are assigned to treatment through random selection. Randomized block design. The experimenter chooses blocks of subgroups with similar characteristics. You could have a matched pairs design. Subjects are matched up according to similarity. One of the pairs receives the treatment and another pair receives a second treatment. And that could be the placebo. Replication of an experiment under same or similar conditions. Replication is important to improve the validity of a study. So doing a study with two different samples certainly improves the results. Ways that you can collect samples. Sample size is the number of subjects in the study. Usually we denote that by N. A census is a count or measure of the entire population. Sampling error is the difference between the results of the sample and the results of the population. And this can occur even with the best sampling methods. So if your average of something for your sample is different than your sample of your population or the entire population, we have sampling error. A random sample is a sample where every member of a population has the same chance of being chosen. A simple random sample, a sample where every possible sample of the same size has the same chance of being selected. And convenience sampling is data collected just by convenience. This one's probably the worst one.
Okay, sampling techniques continued. These next two are often confused, so I'm going to take a little bit more time to show the subtle differences between the two of them. Stratified sample. If a population is divided into different subsets, which are known as strata, so that members from each segment of the population are selected. This is known as sum from all. A cluster sample. If a population falls into naturally occurring subgroups having similar characteristics, a cluster sample selects all of the members from some of the subgroups. This is called all from some. So I know that those are similar, so let me give you kind of a visual example to try and make this make a little bit more sense. In both instances, both the stratified sample and the cluster sample, the population falls into little subgroups. So here I have a population of 20 subgroups, and each of those 20 subgroups have 15 members of them. In a stratified sample, we're taking a sum of the population from all of them. So if I go down here, you'll notice that I have selected at random 3 different dots from each of the subgroups. This is my because I am taking sum from all. And then in the cluster sample, if a population falls into naturally occurring subgroups having similar characteristics, a cluster sample selects all of the members from some of the subgroups. This is all from some. So if I want to look at this one, here I still have these naturally occurring subgroups, but in this case, I am taking all of the members from some of the subgroups. This is your cluster sample, and this is all from some. Hope that makes it fairly clear. Finally, on this page, a systematic sample. Every member of the population is assigned a number and ordered in some fashion. A starting number is chosen at random, and sample members are selected at regular intervals from the starting number. So everybody get in a line. First person is 1, second person is 2, 3, 4, and so on. And for this systematic sample, we're going to take the first person, and then we're going to take every 5th person after that.
So some examples. Well, in order to test for gender gap in the way men and women purchase cars, a company polls exactly 750 men and 750 women randomly selected from adults in the United States. And then to test the effect of graduation of students involved with student council, we randomly chose 4 statistics classes and surveyed 10 students from each class. So if we want to talk about the solutions for this, A is a simple random sample because each sampling group of 750 adults have the same chance of being selected. So this one is a simple random sample because every sampling group of 750 adults have the same chance of being chosen. And then B is not a simple random sample. And the reason that is because a student who does not take statistics has no chance of being selected. All right, moving on. 4 quick questions here. Identify the type of sampling in each of the situations. So I want to read these off. You should press pause and then make a guess based on what we've gone over so far, and then press play and check your answers. First sample the first 100 items from a manufacturing line. Number 2, make a stack of all the statistics final exams and pick every 4th test. Number 3, randomly choose 4 classes and survey the students of those 4 classes. And then 4, from all statistics class, randomly select 5 students from each class. So what type of sampling? Press pause, make a guess, and then come back. 5, 4, 3, 2, 1. Here are our answers here. 1, this is clearly a convenience. E-I-E-N-C-E. Convenience sample. They just pick something easy. Number 2, make a stack of all the statistics final exams and pick every 4th test. This is very similar to the example that I gave for a systematic sample. It is random, but has a system. Number 3, this is clearly a cluster sample. The classrooms better. The classrooms provide natural clusters of students with similar characteristics. But the classes themselves may have different characteristics. And what I mean by that is English classes versus may have different characteristics. So if you're making your selection, your 5 students randomly from an English class, they may have certain characteristics different from 5 students from the math classes. And finally, number four, from all the statistics classes, randomly select 5 students from each class. So this is a stratified sample. And since we're choosing from only statistics classes, students have common characteristics. All right, that's all I've got for today there, folks. I will see you in class. Have a good day. Goodbye.